I collected at my house recently. I think I warned you guys I was going to do this. Fire it up here, hang on. Okay, speaking of bikes. Oops. So I'm a bike commuter, you guys know that. Let me get on that, I'm a bike commuter. And for years I've been riding my road bike to work. It's a Trek Madone, which is nice. I actually have an old Trek 2300 that I broke. Years ago I bought it back in like 94, 95, and at the bike shop I noticed the frame of my old bike was carbon fiber tubes glued into aluminum gussets. So you got these beautiful, beautiful carbon fiber tubes glued into these aluminum gussets. And I asked the guy at the shop, what happens when those break? He's like, oh, these aren't going to break. I mean, they're airplane grade. I'm like, what happens when they do? And he's like, you're not going to break these. I'm like, you don't understand how much I ride. What happens when they break? And he's like, well, if you break it, which you're not going to do, we'll replace the frame for free. So in 2008, the frame broke because I rode it for 14 straight years. That's what I do. And I called Trek and they sent me out this beautiful Madone frame for free, which is a great reason to support the Trek Bicycle Company, because a Madone frame, I think, is what Lance was riding. Not that I care for Lance anymore because of the EPO, but it's a sweet bike. It's a sweet bike, they gave it to me for free. Anyway, I've been riding that commuting for the past, 5 years. And I'm getting tired of having a really nice road bike get slopped on in the weather. Not to mention the fact that anytime I try to take it off the road a little bit, I had to bunny hop off the road to avoid a car or to avoid snow. The rims aren't designed to do that kind of thing. Breaking spokes on my wheels gets a little annoying. So I finally decided to get a cross bike. So I picked up a GT cross bike. Used at one of the used places in town. Kind of a low line one, not that great. I mean, it's got like got some Tiger components. I've been upgrading those a little bit by little bit. But the one thing that scared the piss out of me was the brakes. Anybody, we got some bicyclists in here, yeah? You'll know where you are, yes? There's different kinds of brakes on bikes. Some of you might know this. There's disc brakes, which are all the rage right now. And that's the bomb. If you can get disc brakes on your bike, my mountain bike's got disc brakes, they're great. They stop on a dime. You can actually, if you're not used to them, get yourself in trouble by flipping over the handlebars. Before disc brakes, there were things called V-brakes. We'll show you a picture of those in a minute. Or linear pull brakes. They sit like this on the rings and they pull in like this. Pre that, we have these things called cantilever brakes. Cantilever brakes, they should be called V-brakes, the way they look, and I'll show you a picture of those later. This thing came with cantilever brakes. You can kind of see them in these pictures. I'll show you a better picture later. I haven't used cantilever brakes since like '92. Your road bike kind of has, if you have a road bike, it's got these U-shaped, they're called cantilever brakes on a road bike as well, but the pulling mechanism is different. It's almost like a cross between a V-brake and a cantilever, much more stopping power. Cantilever brakes are okay, like they'll stop you, but they don't stop you anywhere near as quickly as a V-brake or a disc brake. And when you ride like I do, that's a problem. I've laid this bike down a number of times on trails, coming into a hairpin way too hot and trying to stop and just holding the handles in, holding the levers in, and the bike just keeps going straight, so I just lay it down and run away because either that or crash. So I decided, okay, maybe I should put better brakes on this thing. So I went online just to look around, because I don't know much about cantilevers. So I did what anybody else would do. You start Googling, can I put different brakes on my cross bike? Now I couldn't put disc brakes on. I don't know if you guys can tell that or not. I can't mount disc brakes on this because there would be mounts here and here if I could. It's a carbon fiber fork, which I don't think matters, but there were no mounts for discs on the front, and there's no mounts on the back for discs. So I couldn't do exactly. I'm like, what the hell? It's a 2012 frame. Why are there not disc mounts? But there weren't. So I said, my only other option is to upgrade the rim brakes, and the best rim brake you can get is a V-brake or a linear pull. So I went on and looked on a bunch of different forums, and these things are great. Forums like this are great. If you ever need stat help or bike help or any kind of help, just find the threads, find the forums that are on there. There's always going to be people that are just spewing or trolling in there, but you find some good information as well. And I started getting some ideas in here about mini V-brakes. V-brakes won't work for engineering reasons, but these mini V-brakes that I never heard of would work. How's a mini V-brake? So I Googled some more and look. And mini V-brakes, well, I'll show you. So this is a cantilever brake up here. You pull your brake lever up here on the handlebar. This goes up right here. As that goes up, these two things pull diagonally up towards it, and that pulls the leverage in, that it pivots around that point, and then those rim pads go into the brake. So you can see there's some inefficiency there, because a vertical pull this way is being turned into a diagonal pull this way. In physics, you start taking sines and cosines of angles, and all of a sudden the force goes down, which means you're getting less force on the rims. That kind of makes sense? This is a V-brake. You can see why it's confusing why they call it a V-brake when that's actually a V. But these are called V-brakes for whatever reason. And when you pull this brake on the lever up top, it pulls the cable across this way, which means you're going like that, and that rockets those things right in. Much more stopping power. Much more stopping power from a physical standpoint. The question is, can that power translate into better stopping for me? Because more power is great, but if you ever watch somebody on a really powerful motorcycle, they don't know what the hell they're doing, it can be terrifying, right? Like a lot of power doesn't necessarily mean with big power comes great responsibility, or something like that. Or great safety. So I decided to see if this was worth it. I got a pair of linear pull mini V-brakes, and I decided to test them. So I ran a couple experiments. What I did was, this is my house right here. This house up here, it's hard to see from this angle, but here's the driveway on the house across the street from me. So what I did was I did some controlled experiments where I sat at the top with my bike, with the old brakes on, the cantilever brakes on. And then I would just let go in a track stand and let gravity pull me down the hill in a straight line. And then as soon as I hit the curb, right here, I would begin braking power, like I would brake on the trail. Now what you don't want to do if you're a mountain biker, Jack, is going to tell me this, is lock those levers and start sliding. Because if you're sliding while you're braking, you've lost all control. It's just like in a car. You don't want to be skidding across in a car. You want to calmly come to a stop. So that was my procedure. I laid a tape measure. I'll show you in a second. I laid a tape measure at 0 over across the street, which I think was 32 feet or something like that in total. The streets are very wide in this town, I've noticed. I come from Pennsylvania, we're like 18 feet wide. But anyway, I laid a tape measure across. When I hit 0, I'd start braking as if I were, trying to come to a complete stop. And I did a number of trials with the cantilever brakes. Then I swapped out the cantilevers and put the V-brakes on, and then trialed it again. I had Max give me a hand, doing some measurements, so we would wait till my front wheel would come to rest. He'd run out there and he'd find the hub. I would double check him. As you can see where his finger is, where my hub is, not quite the same. So I wanted him to help me, wasn't being interested in the scientific process, let him have fun. But here's the data I got. So, and because Max helped me, this is a little bit goofy, the cantilevers were measured in feet and tenths of feet. And because he laid the tape down and wanted to mess around with it, when he flipped it back over, I didn't realize till we were halfway through that it was in feet and inches. So one more thing for us to deal with before we start analyzing the data. So here's my question to you guys. Was it wise to swap out the brakes and put the V-brakes on? Do you think I'm getting significantly more stopping, or significantly less stopping distance by using the V-brakes? What do you think? What's your gut telling me?
What are the units for the top one?
It's feet and tenths of feet. So 21.1 feet. So 23.5 feet would be 23 feet 6 inches. We can do this. We can do the conversion pretty quickly in our T-guys if you want to just convert it.
That you are better off with
And you're saying that, Rosie, because?
Because you are taking less feet to stop.
Okay, so Rosie's looking up there and looking at the top numbers, and she's seeing a bunch of 20s, and looking at the bottom numbers and seeing a bunch of teens. No 20s at all teens, low teens, mid-teens, high teens. Up top, we got a teen here, teen there, but we also have some low 20s. We got a high 27. What else we got? 26 and a half. So what do you notice with these two data sets? Besides the fact that you've got more 20s up top and more teens in the bottom, does that necessarily mean I'm getting significantly less braking with the V-brakes? I mean, we're getting less. I mean, obviously if we took the average of these two, this would be less than this. But the question I have is significantly less?
Could just mean you're getting better as you're going. Like the same thing we were talking about the stopwatches.
Exactly right.
You're getting more practice.
That's exactly right. So what I did was, did you hear what Michaela just said? It's 100% correct. It's practice. So what I did was, I ran the cantilever test a number of times before taking measurements, and then had him take a few measurements. We took a few measurements. And then with the V-brakes, the same thing. I didn't take the first few measurements because I knew there was going to be experimental error in there. So I tried to practice equally. Yes, ideally, Kaylee, and this would have been great if I had been at time, I would flip a coin each time, and then get two exact same bikes, one with cantilevers, one with V's, and go back and forth. I mean, ideally that would be great, except there's only one of those bikes in town I can find. And switching them back and forth takes about an hour and a half. 4 hours if you're working the time with Max. What does this wrench do, Daddy? Don't put it there. Okay, you put it there. So, I mean, it's one of those things, there's some controls I couldn't control,
right,
so to speak. Thank you, though. You're 100% correct. But that's one thing that should be blinded. Yes, very good, very good, very good. So assume the data's good. It's about as good as I can get it. So assume it's good. So we've 99.9994% of our work is done for us because the data's okay. What do we think? Is there a significant decrease in braking distance for, and let's assume that's all I'm caring about is braking distance. The quality of braking is hard to measure, almost impossible to measure. The quality of braking was about the same. So for me, if I can stop quicker and more in control, then I'm happier. Because that means I'm not going to hit that hairpin at full speed. I will have come down to a reasonable speed before I get into it and with the back wheel and have to go along the way. Jack, go!
You had both brakes on each wheel.
Yes, I swapped them both out.
Okay.
And I know Jack knows this. He's asking this because, go.
Your front brake's more effective.
80% on a bicycle, this is worth noting, especially you road bikers out there. 80% of your braking power comes from your front brake. 80%. It's adorable when you take a road biker on a mountain bike trail for the first time. And they lock their brakes up when they go into a log or a rock and they shoot over the handlebars because they lock both the brakes evenly, not realizing that almost 100% of that power is on that front wheel. When you're coming down a downhill on a mountain bike, try to keep your weight back and kind of feather in that front brake, because if you lock that front brake, you're going to pivot right up. It's terrifying and funny all at the same time. So, good, yes? Yes, okay. So what do you think? Sorry, puberty. What do you think? Did I waste my money? Was the increase worth the amount of time and effort? It was about $100 in parts from local shops around town. I had to rebuild the fork a little bit to actually mount those brakes on after one of the mechanics told me I couldn't do it. Please don't tell me I can't do it. I'm going to do it. But $100 in parts, an afternoon of time. Was it money and time well spent?
I think so.
We think so. Good. How can we know so? With a 95% confidence. Hard, what do you think? You're not even saying it was a good idea. Because you're saying even if it's not significant, you got less braking.
Right.
Right. So if you had to measure this, I guess this is what I'm getting at. If I had to measure this, and I haven't measured this yet. I collected data and brought it in with you guys. Let these guys do it. How would you measure this? How could you take a look at these two data sets and say, okay, here's how I'm going to do it. I'm going to take this, I'm going to take this, I'm going to compare them this way. Michael, go.
Should you take an interval of both of them and see if they overlap?
Let's do that. Let's start with that. Yes. So let's everybody do that. I'm going to turn the camera off. Let's go L1, L2. Yes. And we're going to fix Laura's question right now. That should be 16 feet 3 inches. We're going to fix this, and we're still going to all the same units. So, but first off, let's just put these guys in L1. Once you get here, we'll show you how to deal with this in L2. Turn this off.